Alright, I wanted to make this video to go over the notes that we're going over in class on Wednesday, so today. So last time in class we talked about Charles Darwin and his voyage of the Galapagos Islands. Um, and when he returns to Plymouth, he doesn't go immediately into actually writing this book and putting down his evidence that he spent so long collecting. What he actually does is he's been gone for 2 to 5 years. So I guess I should explain that. He was gone for 5 years total, but he was only on the boat for approximately 18 months. Pretty much any time they stopped at a port, Darwin would get off and meet them at the next port. So he really didn't like staying on the boat because he wanted to explore and collect fossils and do all that stuff. So when he returns 5 years later, what really kind of shocks Darwin is that when he left, there were only hunting dogs. Okay, but when he gets back, there were a lot of poodles and chihuahuas and these pets, which was really weird to Darwin because what he noticed on the islands and what he noticed in the real world was that animals adapted to survive, not to look pretty or look good like these small dogs do. And so he kind of starts forming this theory that maybe humans can shape animals the way that nature does. And we're going to discuss artificial selection here in a minute. Okay, so what Darwin does is he comes home, he notices these small dogs, and it kind of throws him off, but he logs it, keeps it in the back of his mind. Um, but again, like I said, he doesn't write his book on the origin of species for 20 years once he returns. And in that 20 years, he starts a family um, with his cousin, Emma Wedgwood. They get married shortly after he returns from his voyage. They have 10 children. So out of 10 children, three of them died before the age of 11. And then a couple of them had severe disorders, socially, mentally, physically, after that. So seven of his 10 children survived past 11, but most of them had some sort of abnormality, whether it be social, emotional, or physical. Okay, and what Darwin kind of writes and studies is his own family's lineage. Okay, the Wedgwood and the Darwin families, this isn't the first time that they interbred. So, what he kind of talks about in his book on the origin of species is that if you keep your lineage, so two families, too close, they're not going to be evolutionarily fit. And he discussed how, they lost three children, and the children that survived weren't physically adept, weren't physically fit to survive. So, kind of what Darwin says is that humans can choose what traits. So, whether that be by choosing your mate, who in Darwin's case was his first cousin, or by choosing um, small dogs, big dogs, we can choose what traits get passed down to the next generation. So, this idea Darwin really expands on when he takes up the hobby of breeding pigeons. Okay, so Darwin breeds pigeons. He takes birds with big beaks, mates them with small beaks, sees what happens. He takes birds with brown or darker feathers, mates them with lighter feathers, and he sees what happens. And he does this to determine what he calls heritability. Heritability is the ability to inherit a gene. Okay, so to pass the gene down from one generation to the next. And if we're looking at Darwin's ideas and philosophies, remember when we talked about Darwin last time, one of the biggest or best things that he does for himself is he writes down all of this information. Okay, so he's taking up this breeding of pigeons. He's looked at these small dogs and said, okay, how are we making smaller dogs? And he studies his own family. Okay, to kind of come up with this idea of fitness, the ability to survive and pass on your genes to future generations. Okay, and Darwin, like I said, Darwin doesn't come home and immediately publish his works from the Galapagos Islands, and this almost bites him in the butt. Okay, because 20 years later, Darwin gets a visit from a local professor, a local biologist, Sir Alfred Russel Wallace, and he comes in 1958 and tells Darwin, "Hey, I think I have this theory You've put out some publications. You haven't really published all of your findings of the Galapagos Islands. But Sir Alfred Russel Wallace basically shows Darwin this paper that he's going to publish saying he believes this theory of evolution is occurring, and he's got all this evidence from right there in Europe, how animals have changed over time, especially now with civilization kind of booming. Animals have to adapt to all of these European migrants. So Darwin gets kind of offended. He's worked over 20 years at trying to perfect his theory of natural selection, and Darwin's a little competitive. He knows what's going to happen if Sir Alfred Russel Wallace publishes first. So Darwin actually tells the guy, like, hey, I'm going to look at your paper, gives him some pointers, but really kind of holds his own cards, I guess is what you would say, in the fact that Darwin doesn't immediately tell Sir Alfred Russel Wallace that he's going to write his own publication. And what kind of defines this moment is Darwin actually publishes his work first. So in 1859, Darwin published his book On the Origin of Species through natural selection before Sir Alfred Russel Wallace could. And so now, instead of studying Sir Alfred Russel Wallace, we study Charles Darwin's theory of evolution. So Russel Wallace, Sir Alfred Russel Wallace, kind of comes in second historically because he didn't have that trip to the Galapagos. He only studied European species, and Darwin kind of took advantage of that hospitality or that friendship that Wallace kind of extended and published his book first. Okay, and in Darwin's book, he opens it up by discussing his trip to the Galapagos Islands, how natural selection has occurred, and what his theory is that natural selection is a mechanism by which organisms have inherited beneficial adaptations. So the finches, the tortoises, the whatever animal we're talking about, the only reason that they were still there was they had some trait that made them survive better than the other organisms on the island. Okay? And Darwin, or you can look at this drawing here, okay? Here in step one, we have a mix, about 50-50, of thin-furred deer, which is the lighter color, and thicker-furred deer, which is the darker color. Throughout time, throughout winter, what we notice is that not every species survives, right? There's not enough food. There is a carrying capacity here. And then through the cold winter months, the ones with thicker fur survive. And you can see at the very end, the next reproduction cycle, because there were more thicker fur than thinner fur, as the species grows and develops, they will have thicker fur because of it. Okay, so Darwin comes up with these 4 principles or 4 chapters of his book, and these are variation, overproduction, adaptation, and descent with modification. Okay, so we've got Darwin's introduction. He lays out this idea that natural selection occurs. He discusses all of his evidence from the islands. He shows like that artificial selection also occurs, and now he's got these 4 ideas that he's going to kind of, for lack of a better term, going to use as chapters or markers for people to understand that without these 4 things, natural selection cannot happen. Okay, so the first thing he argues is that variation is important. Okay, what might be attractive to one person will not be attractive to another person or another organism. Okay, so if green eyes is more attractive, then more people with green eyes will reproduce, and therefore blue eyes and brown eyed people are not going to survive because that gene is going to die out eventually. Because if they're not found attractive, no one's going to mate with them. Okay, peacocks do this with their plumage, their feathers. A lot of different species have different characteristics that they look for, but without variation, we don't have those different traits. If we didn't have variation, everybody would have one specific trait. Okay? All right, so here's a good picture of different types of variations amongst butterfly wings. Lots of different colors, lots of different shapes. Each of these has their own difference and just a physical characteristic. Remember, variations can be genetic or physical. We're only focusing on the physical differences right now. All right, the next step, overproduction. Okay, so Darwin argues that natural selection cannot occur without some sort of competition. Okay, if there's no way or if there's no reason to test out strength, we'll never know who the strongest one is. Okay, so what he says is that we're going to keep reproducing. Animals will reproduce, they will have babies, unless there's not food available or if there's not space. And what happens is there's a competition between the new generation and the old generation. Okay, that overproduction leads to this competition, and ultimately, when we compete, you either win or you die. So if I'm eating, then whoever isn't eating is going to die because they're not eating. So Darwin's idea of overproduction was that some finches didn't survive because the more fit or better adapted finches ate the food and survived. All right, so thinking back to density dependent and independent limiting factors, remember density dependent means it depends on the number. Density independent says it's going to affect it regardless. Would overproduction fit into density dependent or density independent? I'll give you a second if you need to pause the video to answer that. Go ahead. All right, so this is a density dependent limiting factor. Keep in mind that the idea here is that the number of organisms directly affects it. Okay? Density independent would mean that no matter how many babies were made, there would still be enough food. And that's incorrect, right? There's only so much food available. So the number of babies is going to play a direct factor in that. All right, adaptations. Darwin's main argument with the finches was the bigger the beak, the better suited you were for the mainland. The smaller the beak, the better you were suited for the islands, the further away, based on your food, right? That adaptation alone. Okay, we can't think about artificial selection here as an adaptation because we have messed with genes so much or traits so much that we don't care if they're suited for the environment. We're going to establish that environment. Okay, one of the best examples today are pugs, right? We have made this squashed faced breed. And if you look at the x ray of a pug, you can see that evolutionarily thinking, like that face should not exist in nature. But because humans throughout time have been able to breed and choose specific traits that they like or they want, pugs or poodles now exist. All right, and then last but not least, I kind of talked about this picture in class on Monday, but what we see here is this is the original finch, okay? And Darwin's final chapter in his book talks about how descendants, so the ones that we saw today, are different than the ancestors, the ones that existed 50, 100, 1,000 years ago. And what you notice, this guy's relatively small. Look at this pointed beak. But then as we go throughout the different species that are found on the islands, genetically they're similar, but physically they look very much different. Okay, if you look at this curved beak or super pointed, more like a talon than anything, okay, the idea here is that because they had to adapt, because they had to change to their food, or the trait that they had was more beneficial for the food, not necessarily that they could just pick up their beak, rip it off, and then put on a new one, okay? But the idea here was that this beak seems to do better on this island, so the ones that already had this kind of curved beak survived better and reproduced. Okay. All right, so I just kind of have some pictures up here of variations so you can see a difference in physical traits. Overproduction, meaning that one of these three probably isn't going to survive because there won't be enough food for three of them. There's probably only food for one or two of them. Adaptations, these guys have really nice pores in their skin and their fur to allow them to dry so that they're not just waterlogged all the time. And then descent with modification, the babies look different than the parent. Okay, that's all for today's notes. So I'm going to pull up your peppered moth assignment. So if you're at home watching this video, we're going to go into this assignment right here, Peppered Moth Simulation Alternative. Okay, you're going to open this up. It's a Google Doc. And basically what's going to happen is you're going to go to this web link that's slowly loading. Go to this link. You're going to be taking notes. Take at least 3 notes per section. So there's the peppered moth section, the natural selection, and then the selection section, and then the Dr. Kettlewell. And then this 4th section teaches you how to play the game. It's very straightforward. You're just picking off butterflies, moths, as much as possible. You can see my 2 screenshots down here. At the very end, once you've done a minute, it gives you a graph. So go ahead and take a picture of this graph with the data. It also has this print option. If you want to do the print option, that's fine. I did not. Don't worry about it. It's an extra step. And then once you've kind of done that, kind of tell me what's going on with the 2 populations. Why in this one did the light moth survive better for me? Maybe they don't for you. In this one, my dark moths survived very much better. Why? So down here, kind of write a few sentences to explain that. Okay, I'm not going to say like a 5 to 7 sentence paragraph, but I would say at least 3 or 4 sentences telling me what's going on between these 2 graphs. Okay, if you have any questions, please send me an email. Thank you.